Let's talk now about combinations. Now, we talked before about permutations, and again, just to refresh your memory, these things are very, very similar. We're talking about, groups of items and how many different ways can we get different groups out of a certain number of people or things or whatever. But the difference is that permutations are in a specific order. Combinations are just groups of people. So I think the example that we used last time was um, a, a a team, a baseball team, would be considered a combination of people because it doesn't matter, how they're standing or listed or whatever. It's still the same team. Where it becomes important about their order would be like in their batting lineup. So if you had people in a different order, then it's a different batting lineup. So that's a permutation. Okay, we have a formula for combinations, which you're seeing now on your screen. But we can also do combinations on our calculator. So this is very nice also. Let's see how this works out. Says the Library of Science Book Club offers 3 free books from a list of 42. How many possible combinations are there? Well, just like when we were doing our permutations, we need N, which is our total number of objects, and R, which is how many we're using in a group at a time. So in this case, we have our N, our total number of items that we have to choose from would be 42. And we're going to be choosing these in groups of threes. Now, the reason that they're combinations is specifically because it said combinations, but that word can be a little bit misleading sometimes. But it doesn't matter if you choose 3 books. It doesn't matter what order they're in, they're still the same 3 books. So that's why this is a combination and not a permutation. But yet our notation is very, very similar. We always say our N and then C and then our R. So it looks like 42C3 in order to put it in on your calculator. So let me show you how that looks. We start off with our initial number 42 and then go to math, arrow over to probability, and now do you see that the number 3 choice here has NCR? So I'm going to choose number 3, and then it looks like NCR on my screen now, so I'm going to type in 3 and hit enter, and I get 11,480. So that would be 11,480 different combinations of 3 books out of 42 that we could have. Right. Now, be careful when you're working these problems and when you're thinking about combinations and permutations that you're constantly being aware of why you're choosing a combination or a permutation. Because a lot of times they'll throw things in there where you'll have to decide, is it a combination or is it a permutation? And we want to make sure that we're deciding the correct one. So in this example, it says, assume a class has 30 members. In how many ways can a president, a vice president, a secretary be selected? So let's think about that for a second. Is that a combination or is that a permutation? We're talking about a president, a vice president, and a secretary. So is the order or the arrangement of people important? If Joe was president and Sam was vice president and Fred was the secretary, would that be an entirely different setup than if Sam was president and Fred was vice president and Joe was the secretary? Sure, it would. That'd be 2 completely different administrations, wouldn't it? So in this case, the order is important, which makes this a permutation. because the order being important here. So we have a total of 30 members, so that's our N. We're doing a permutation and we're choosing 3 things at a time. So our R would be 3. And now then let your calculator finish that out. 30 things. Go to math, arrow over to probability, and choose number 2 for NPR. 3 at a time. Enter, that would be 24,360. 24,360. So there's that many different ways that we could get a different lineup, different administration there. Part B says how many committees of 3 people can be chosen. Well, again, we need to ask ourselves, is the order important? We're just talking about committees of 3 people here. So does it matter whether it's Fred and Sam and Joe or Joe, Sam, and Fred? That's still the same committee. It's still the same grouping of people. We're not talking about them having specific roles at this point. So in this case, this would be a combination. So we would want to choose our N would be 30 again because there's 30 total class members, but this is a combination and we're picking them 3 at a time because these are 3 people committees. So we would go to our calculator then and do 30 math, arrow over to probability. Oops, went one too far. Choose number 3 for NCR. 3 is our R value, and hit enter to get 4,060. So that will equal 4,060 different combinations of 3 people committees that we could get out of those 30 members. All right, now we've talked about permutation, the fundamental counting principle. We've talked about permutations and we've talked about combinations. When we talk about probability, remember, keep in mind probability is nothing more than total success over total possible. So let's keep that in mind as we're going through this last problem. This last one says a 5-volume numbered set of books is placed randomly on a shelf. What is the probability of the event that the books will be numbered in the correct order from left to right? Okay, well, we're talking about a permutation to begin with because we're talking about order being important. So this is a permutation. And there are 5 things, so 5 is our N, and we're going to use all 5. So 5 will be our R. So that would be 5 things, permutation, 5 at a time. Now again, let's let our calculator do that. So 5, go to math, arrow over to probability, choose number 2 for NPR. 5 things taken 5 at a time will be 120. Now let's think about what that means. That means there are 120 different ways for those books to be put on the shelf. We wanted a probability. Probability, remember, probability is successes over total possible. So in order for us to be successful here, there would be one of these groupings that would be in the correct order from left to right. Out of 120 possible groupings. So the probability would be 1 out of 120. We want to be careful about whether we're asked for just the total number of ways something can happen or the probability, because then we have to go back to successes over total possible. So be careful that you're reading your directions very carefully.